So, I welcome you all for day three of our project session. Uh, Yesterday, we ended up with finding the correlation between the features and those features which are highly correlated and least with the target. So, I have filtered some features from the data, and now we are available with only those features which are least correlated among themselves, and we are having these features which are in good correlation with the target. Okay, fine. So now what we can do next is this code. Also, I told that I want to utilize time in my analysis. Okay, so I cleaned the time with the help of a regular expression. I extracted year, month, day, and hour from the time. Okay, because I did tried with one of the method of time conversion, that is date time, but unfortunately that was throwing an error because the pattern was not proper. So I did one thing: I applied regular expression and I extracted year, month, day, and hour from the time. Okay, fine. And then next, initially I dropped my time feature because now I already have the features which I created separately, that is year, month, day, and hour. So I don't require initial time feature, so I dropped it. Okay, and then next, I again printed that these are my final columns over which I can end up with the analysis. And to be like applying different machine learning algorithms, dfnew is my final data frame, but I want to apply different machine learning algorithms, and every machine learning algorithm has some expectations over the data. So what I did is I created copy. So dfnew copy one I created in form of df1, another I created in form of df2. So two copies I created, df1 and df2. So whatever be, I will experiment on df1 and df2. So my df new will be kept safe. Okay, so I started with df1 initially, and as we very well know that right now the problem statement with us is a regression problem. That means your target is price actual, this is what you need to achieve, and price is continuous in nature. So this is your target. Fine, and target is continuous, that means you are dealing with a regression problem, and for that we will be using regression algorithms. Okay, so what I did again, I took my df data frame and perform classification of features like categorical, non-categorical, discrete, and continuous. The code of classify features I have already made above. If you remember, I have already made above the code for classification of features. Okay, now what is the reason of doing this thing? Why I am classifying my features? See, there is a reason, and the reason is, let me share my entire screen. I want to talk about why I am doing this thing. As said, every machine learning algorithm is having its own requirement. My goal here is to apply linear regression as one of the algorithm. My first algorithm is linear regression. Okay, so linear regression demands that the continuous features present in the data, they should be in normal distribution. They should be normally distributed. However, we have already seen the orientation of continuous feature in our data. They are not normally distributed. So I just want to alert you at this particular point. Don't apply algorithm directly unless and until you don't know what is the requirement of algorithm. Don't apply data to any algorithm directly. There are rules before applying a data to a model. And if you are applying LR, linear regression, it says that your continuous feature should have to be normally distributed. If they are not normally distributed, kindly apply transformation over it. And there are different types of transformations, like you can calculate log of the feature, you can calculate square root of the feature. These are the two basic types of transformation in which I have used log transformation. You can see the code. Okay, in code, what I did, see here, every feature in continuous, I have applied log of it. And one additional work I did is I added 1 before applying log. Okay, this is my feature. I added 1 to it. Why? What is the reason? See, if the value of a feature lies between 0 to 1, or if it is less than 0 or equal to 0, if it is, especially if the value is less than like 0, so negative log will not be going to perform anything. It will fill up with null values. Log 0 will also be like NaN. So unnecessary my data will have null values, because log will fill up with NaN if you have the 0 or negative values inside the log. So, in order to preserve myself from that, I added 1. Okay, so it will help me in not getting the NaN values. Okay, so this is very important step. So I performed log transformation of continuous features. Okay, yes, ask the question.
Sir, I want to ask one question. Is that means since this is a time series forecasting,
Hmm? Time series
so
forecasting.
the thing is seasonality trend pattern. Have
Huh.
it usually check
Sir, that we
further
will
or
see in time series algorithms. Right now, we are not applying any time series algorithm, sir. Right now, we are
okay?
applying regression algorithm.
Yeah, because the log transformation you mentioned.
Hmm,
So
hmm,
because most of the time we apply for the making it as stationary part.
hmm,
So
hmm,
that is why I asked.
hmm. So, log transformation we have taken, and it's one of the suggestion given in order to convert a feature into like, or likely to be. We will not say that after applying log, your feature will entirely convert into normal distribution. No, it will not convert. It may happen, it may not happen. Okay, so it's just a suggestion given. Either you can apply square root, either you can apply log, and there are different other transformations also. For example, we are having standardization techniques also. Standard scalar, robust scalar, depending upon the situation, normalization. There are different techniques to transform your data. I am applying log as a simple transformation technique because this is my requirement of a linear regression algorithm, that your continuous feature should have to be normally distributed. If it is not normally distributed and you are putting here in the algorithm, then it will give more error. Okay, it will give MSC highest. Okay, in that particular case, mean square error will be high. So, just in order to regularize my data, I am performing transformation. I applied log as one of the step to perform the transformation. Okay, we are not talking about the trend. We are not talking about the seasonality. We are not talking about any time series concept here. Just transformation as per the requirement I am talking about. Okay, and after doing the transformation, here you can see the values are converted. I again printed my df1 data frame, values are converted, and now I am having the log values for the continuous features. Okay, and then again I made this like histogram for the continuous features to check whether they have converted into normal or not. Okay, so if you check with this transformation, we got changes. Absolutely, there are changes in the features. This is the change, this feature also change. Now you can see they are looking like some orientation like normal, not fully. I'm not committing that they are fully connected like to be as a normal, but there is a change in the orientation, and this change will help us in fitting the data into the model. So it is a tip for everyone: before applying linear regression, kindly do perform the transformation over continuous features. Okay, so you can see there is a change. Initial histogram and after transformation histogram, there is a change. Okay, and then here I imported linear regression, train test split, all these things, mean square error, R2 score I took. Okay, and then I have dropped the price column and I took it on y axis. I applied a train test split to split the data. Okay, and I put my x train and y train in the regression model. Okay, in linear regression algorithm, I put training data. And once my model got trained, my linear regression got trained, okay, then I can perform the prediction. That means for prediction, I am taking X test. Okay, that's what I am taking. And this is my Y prediction. These are the predicted values. Once your model got trained, now you can apply for the prediction. Okay, done. And then you are available with y test and y prediction. These two are having. Okay, so you trained your model on x train and y train. You calculated prediction over x test. However, x test already have y test as output. Now you have a chance to compare y prediction and y test, that whether these values are same or whether they are different, and if they are different, how much different they are. That is called as error. Okay, so that's an evaluation criteria for a model. So here I am calculating the error between them. Okay, and I am also calculating R2 score. R2 score means how many predicted points are coming over the actual line. Because in regression, you are having a line. You are using linear regression. No? So in regression, you are having a line. This is actual. And you will be getting the predicted points. So how many predicted points are coming over the line? That is defined by R2 score. Okay, if all the points will come, then obviously somehow what there could be a question that whether your model is overfitted or what. So we do expect some errors to justify ourselves that okay, no, my model is not overfitted. There are some errors. Okay, because in real world we do have some errors. Okay, fine. So you can see my R2 score is 54 and error is 0.04. So error is very less. And R2 score is also good, 54. That means 54 percentage of the data points are like they are captured by the actual line. The rest are not being captured. It's okay, fine. Error is very less. That means they are nearby the line because error is less. And here is the plot. You can see. This is the plot. So green now, these green which you are seeing now, these are predicted points. The model predicted, and red is the actual line. Okay, red is actual and green is predicted. Fine. So this is how you can show the plot. Okay, between actual and predicted. Okay, so such result I got from linear regression. It's a good result. Then I applied another algorithms also, like support vector regressor, SVR, DTR, RFR, that means support vector regression, decision tree regression, random forest regressions. But these algorithms don't demand log transformation data. No. I already told you. Every algorithm has its own demand of data. So SVR, DTR, RFR, they don't want such kind of data, log transformation. SVR demand for a data which is scaled. DTR and RFR, that is random forest and decision tree, they don't demand in such neither scaled, neither log transformation. No, they only demand that features should not be correlated. Should not be correlated. So that we have already calculated, and we have dropped the highly correlated features from the data. So in DTR and RFR, we are having straightforward chance to put the data inside it. However, for SVR, we have to scale the data, scaling, and that too is standard scaling, standard scaler. Okay, so here you can see what I did. With DF2 also, I perform the classification. These are my continuous features, and I imported standard scaler for pre-processing of the data. What is standard scaler? Again, it's a way to transform your data, to scale your data, and especially the scaling has been done over the algorithms which are distance based algorithms. So SVR, support vector regression, in supervised machine learning, is a distance based algorithm. So here scaling is required. Okay, because if any of the data point is very much far away from the hyperplane, okay, it's better just to scale the data point. Those who know about the algorithm in depth. Okay, so the formula for standard scalar is x minus nu upon sigma. Nu is the mean, sigma is the standard deviation, and x is a point. So from point, subtract the mean and divided by the standard deviation of that particular feature, particular column, you will scale your data. This is standard scalar. That's what I did here. Okay, I took my continuous features. I fit all these continuous features to get scaled. Okay, and after scaling, okay, I got my scaled data frame. And then I used SVR, support vector regressor. Again, I took price actual as target. Rest are my columns for training. I divided the data into train test. Okay, and here I put X train, Y train in SVR. Remember, that's why this is a pro tip. This project, it's maybe some people might be knowing, but unless and until you don't apply the correct strategy, you will fail. You have to execute the entire process with a planning. Okay, and that's why I'm telling you that this model require this thing, this model require this thing, this model require this thing. It doesn't mean that you have performed all EDA, you have performed all visualization, and you are ended with this final. No, model also require data. It is having expectations. So you scale the data for SVR, log transformation for LR. Okay, so here I did the training with SVR. Here I calculated the prediction. Okay, and once I'm done with this thing. So I printed the error and the R2 score. So error here in SVR is a bit high than LR, that is zero point 0.9, but it is less. Zero point 0.9 is not a big value. Zero point 0.9 and the R2 score is 10. Okay, that means 10% of the values are being seen over the actual line. Data points are seen over the actual line. Okay, rest are nearby. And this is how I can plot it. So this red dotted is the actual line. Blue are the predicted points. So 10% of the points are just been here, just putting on the line. Rest are not far away, but closer to the line because error is less. Only zero point 0.9 is the error. So these are the predicted points. Blue points are predicted points. Okay. Now with the same phenomena, I used I used okay, I can find, I guess, dysentery regression and random forest regression are skipped. Okay, but I can use them in the same regards. Okay, so either you can have a code like this. Okay, I guess like this. From SK, okay, just a second. Okay, here, no? Like this here. Okay, code. Okay, so from sklearn dot tree import decision tree regressor. You can import this decision tree regressor from decision tree. Okay, and what you can do next is just the code which you have used above, just like SVR. Okay, this thing X train and the Y train. Control C, you can put it here. Okay, instead of SVR, you have to write this thing decision tree regressor. Control C, Control V, and this will be DT model. Okay, you can write here as DT model. Okay, DT model, and this will be DT model. Okay, fine. And then later on, you can check the prediction from the DT model once it get trained. So you can have Y prediction equal to DT underscore model dot predict X test. Okay, and then next you can calculate the scores. Fine, you can find the scores like this. Control C and Control V. Okay, I'm not executing because yeah, it will be because my code is already executed. But I think I skipped this part, so here I'm putting dysentery regression. Similarly, you can use random forest regressor also. Okay, so this part of code you can execute. I'm saving this and you will get this part of code. Okay, fine. So this is the way we can use machine learning algorithms in our data to perform the prediction. I included deep learning also. How? This is my next structure of code for the deep learning. All these are my training features. This is my target feature, price actual. I took training on X, target on Y. Okay. I perform the splitting as usual. That's what I do. X train, X test, Y train, Y test. That's what I do. Now, again, a tip. Deep learning model also require scaled data. Remember, if you're sitting with some notebook, if you're sitting with something where you can write, you can. Don't forget. Deep learning also require scaled data. There is a reason because the working of deep learning model is in this way. See, you do have layers in deep learning, neural network architecture. Okay, and this is how you give the inputs to the neurons which are present in the layer. Every neuron is connected to every other neuron of the next layer, and the mass which is applied here is Wx plus B, where W is the weight, X is the input, and B is the bias. Okay. So if you don't scale your input, if you feed huge values, huge values in the model to give to the neurons, obviously it may happen that, okay, this value might be 100, this may get 10, this may get 1000. We are not expecting such kind of variable values, so it's better that you should scale the values. Okay, scale the values and then feed it into the model. And this is not only the thing which we do, wx plus b, y equal to wx plus e, whatever be the y we are getting, we give it to the activation function. There is an activation function in deep learning. There are many activation functions in the deep learning which are non-linear activation functions. For example, ReLU, sigmoid, 10H, etc. These are famous activation functions. Okay, so in the code, what I did is I first performed the transformation, scaled my data, then I am using TensorFlow as a framework. TensorFlow is a deep learning framework. PyTorch also. There are many frameworks. Here I am using TensorFlow. See, for example, machine learning ke liye you are having sklearn, scikit-learn. For deep learning, you are having TensorFlow and PyTorch, two famous frameworks. Okay, so from TensorFlow, I am taking sequential model and I am taking dense layer. Okay, so your model is sequential. Sequential means feed forward. Okay, this will be your model. Okay, like this, sequential. These all are the layers. You are available with the neurons on the layers. Okay, and your model will progress in forward direction. And here you are going to get the output. Okay, so the kind of architecture which I built in this particular case is I took 1, 2, 3, and 4. 4 dense layers I took. Dense layers are the layers where the actual computation takes place. These are highly interconnected layers. They are also called as hidden layers. Okay, so 4 dense layers I am taking. Okay, so let me again make an architecture. 1, 2, 3, 4. And I took how many neurons on them? Neurons are the computational units. First dense layer 64, second 32, then 16, then 1. Now the question will come, sir, how do you know that this much neurons you have to take? See, architecture development in deep learning is a subject of expertise. It's a subject of your practice. I am giving you this architecture, you can build any other architecture which may show better results. So, here in case of deep learning, it's not fixed. We just develop architecture, we just build such arrangement, and we see how much scores we are getting. There is nothing fixed here. You may take many more dense layer. You may take any other layer also. You change the neurons, number of neurons. I took 64, 32, 16, and 1. Okay, so this way. So 32 neurons here. 1, 2, 3, 4, 32. 1, 2, 3, 4, 16. Then 8. And then at the last layer, I am taking one neuron because only I need to give one answer. That is the regression price. So only one neuron is required for that to show the output. Rest you can use it for the training purpose. So here are my input features, and from 64 neuron to 34, 32 neurons to 16 neuron. Okay, this is 16 and 1. Okay, so every neuron will be interconnected. Here also every neuron will be interconnected. Here also every neuron is connected to this. And what kind of mass was happening inside? Wx plus b. And also I took activation function. The activation function which I mentioned here is ReLU. You can see ReLU, activation function. That is rectified linear unit. Okay, a rectified linear unit, this ReLU function means if the input is negative, output is 0, and if the input is positive, output is same. This is ReLU function, rectified linear unit. If input is negative, that means if you are having minus value, output is 0, and if input is positive, output is same, positive. This is what ReLU do. Okay, so I'm using here rectified ReLU activation function. Okay, fine. And here, okay, my architecture is over. Very simple architecture I used. Then I compiled my model. I compiled my compilation means to configure your architecture. Compile means to configure your architecture. Okay, configuration means okay, you have developed architecture. That means you are available with the components of the architecture, but unless and until you don't add the working principle in it, how you can make this model to be in an active mode. Model development, architecture development is an infrastructure. That's what you build. But you have to make it in active thing, एग्जीक्यूटेबल फॉर्मेट में आपको कन्वर्ट करना पड़ेगा उसे, तो उसको कन्फिगर करना पड़ेगा. Okay, that's what you have to do. You have to configure the model. Okay, fine. So यहां कॉन्फ़िगर करने के लिए you have to take optimizer and the loss. Optimizer I took Adam, loss is MSC because errors ना, regression का problem है तो error आएगा, accuracy नहीं आती, error will come. Okay, this is my model summary. Model summary will print that okay, what you have done. Okay, one dense layer 64 neuron, another dense layer 32 neuron, another dense layer 16 neuron, finally dense layer 1 neuron. That's what you did. This is your model summary. And then here is a training process. So I took X train and Y train data, that is the scaled data. 50 times I'm iterating my model. Okay, 50 times. It is taking 50 steps to train. It's up to you how much steps you want. I took 50. Okay, you can take 100, depends where you are getting the good score. So 50 validation split, point 2 validation split means I'm taking a part of data from the training to validate my model during training only, that the working of model is going correct or not. Okay, whether your model is showing good score or not. So just validate at the execution only. Verbose means to to store the log files. That means for the training, whatever be the results I am getting, so to have a log file like that. It's not mandatory. You can ignore this part also. Okay, fine. And that's it. This is how I train my model. 50 iterations. And after 50 iterations, once my model got trained, I perform the prediction as I did in the machine learning. Same I am doing here in the deep learning. Model dot predict. Okay, I perform the prediction. And after prediction, let me check the score. So here the score error is 21.69. Now, here you will see, sir, error in case of machine learning was less. That was like zero point zero 0.04, zero point 0.9. So error was less in case of machine learning. But here, in case of deep learning, the error is more. But one thing is very much interesting here. Check the R2 score. R2 score is 0.89. That means my model is capturing the actual line 89%. 89% of the predicted points are coming over the line. Okay, and few points are far away from the line. That's the reason mean square error is 21.69. थोड़ा सा error ज़्यादा आ रहा है. वो कुछ points हैं. There are certain points जो actual line से थोड़े से far away हैं. That is why error is 21.69. But R2 score is good. Okay, and when I draw this thing, you will you will see. Okay, let me draw. हाँ ये रहा देखो. This is one of the best plot which I obtained. Let me reduce the size. Okay, here, if I reduce the size, you can see this red one is the actual line, blue are the predicted points, and they are just coming in this order only. However, if they are certainly far away, error is more, but they are good captured. Okay, predicted points are coming more on the actual line. In SVR, we have seen that there is like change in the orient, but here it's just like following up the actual line. So red is the ideal fit. Okay, red is the ideal fit, actual line. So we are not expecting any ideal thing like that. No, but your score should have to be good. Okay, fine. This is what we have got. Okay, so with deep learning, we are having good results. And also, I want to show one more thing. See, you have trained your model. You have trained your model, and all are stored in history. Your entire training program is stored in history. You can make plots for the history. That's what I did. These are my history plots. Okay. And in history, I am making a plot for training loss and validation loss. Training loss and validation. Whatever be the losses I got in the training, what are the losses I got in the validation? That's what I'm making. Training and the validation losses. Okay, so you can see during the model training, the loss get less, and that is what we expect. That is what we expect. During training, the loss should reduce. Loss should not be more during training. If the losses are getting more, that means it's quite clear that you did a mistake in the architecture or in taking in pre-processing you had some issue. Okay, so ultimately loss should reduce, it should not get more, huh? If we were dealing with the accuracy also, that is in the classification, so accuracy should increase with the training, losses should decrease with the training. That is what the expectation is. Okay, understood. So here we can see that loss is decreased, and also I made a plot between actual and the predicted prices. You can see. Okay, I've already shown you about this thing, and it's quite clear. So this is the loss, and this is the prediction plot. Okay, so this is how we can make a deep learning code. Okay, so this is my deep learning code, one architecture which I have built. So machine learning also I used, deep learning also I used. You can compare in your project. So it's an overall project. And then comes one more thing, that is time series. Now, what that issue is? What is this time series? See, so far the kind of analysis you have done is regression analysis. What happens in regression analysis? You are having a target which is continuous in nature. That means you are having price, and price is continuous in nature. Okay, that you have taken as a target feature. And for that, you have used regression algorithms, linear regression, decision tree regression, random forest regression. These you have taken. Okay, but in our data set, we do have time column, and in any of the data, if you are available with the time column, you have a flexibility to use another algorithms apart from the regression, that is time series. And what happens in a time series is, now what happens in a time series is, because you are having in time, that is 2015 year, you are having month, you are having day, you are having hour, minute, second, they all are in a sequence way, all are in a sequence. That means this entire date is in a sequence. Okay, so once your hours are finished, 24 hours are over, the date will change. So you are having a sequential data, remember, sequential data. And time series is applicable on such kind of data, sequential data. It is applicable on sequential data. Okay, fine. So in time series, what you have to do is, we don't care about we don't care about features. Okay, we don't care about the other features apart from target. Okay, we don't take care about that thing. Okay, we just only take time and the target feature, only these two we take. We don't take what is the coal, what is the coal, what is hydropower, what is any other energy production. No, none of the feature has been considered. We just only take time and the target. So what it means is, okay, at this particular time, this is the price, this time, this is the price, this time, this is the price, and so on. That's what we are going to take. Doesn't matter what are the other features, ignore all. So such kind of problem, it's a sequential data and it comes under time series. Okay, so I have used time series analysis here. What I did is, again, I took this regular expression date time, because I need to fetch only the same logic na, year, month, day, and hour. That's what, hour plus minutes also and second also. This is what I require, because in your time you are having all these things, along with that one UTC time standard. You are having this thing. I don't want this. I just want year, month, day, hour, minute, second. That's what I want, not this UTC time standard. That is why I applied regular expression to fetch all these. Just only this thing. I want my date to be in this thing. Okay, so I applied regular expression to perform this task. Okay, I created another data frame DF3. Obviously, now I need to do separate analysis. So DF1, DF2, DF3. See why I was able to do that, because my DF cleaned. This is the original the data frame. It's I kept safe. Rest I created copy, and I am working on copy. So my main data frame is safe. So anytime I can make a new copy of my existing data frame. Okay, so here I created a copy df3, and df3 the time feature. In the time feature, I applied this code to extract what I require. Okay, I applied that thing, what I require. Okay, and then I created new data frame df4 from df3, which is having only time and the price data. Only time and the price. That's what I was telling you right now. I don't require rest of the features. I don't require anything. नहीं, बस मुझे तो ट्रेंड चाहिए. मुझे डेली ट्रेंड चाहिए, चाहे वो आवरली बेसिस हो, whether it is in a minutes, whether it is in a seconds. I require a trend, regular trend मुझे चाहिए. That I say is a sequential data. बाकी मुझे कुछ नहीं. I don't require anything else. Okay, so time and the price. That's it. So this is my new data frame df4, which is having time and the price actual. You can see only two columns. Then what you have to do is you have to set index time. That means bring time on the index side. So in df4 I brought time on the index side. This is on my index. That's what you have to do. And after bringing that into the index, I just made a plot. I just made a plot of price actual, price actual with index. Okay, index on x axis, price on y axis. I just made a plot. So on x axis I am having time, y axis I am having price actual. Here is the trend. This is how you can see the trend. Okay, price actual and your time versus price. This plot. Okay, I am going very easy. I am making you to learn the time series in a very easy way. That's what you have to follow. Okay, then after that, what I did is I checked, are there any duplicate values in the index? It may happen because some wrong. Okay, हो सकता है वो टाइम रिपीट हो गया हो, फॉल्ट इंट्रीज हो जाता है. There is a possibility. So I checked for the duplicates in the index and I found that there are some duplicates. These are the duplicated values in the time. Okay, what I did is I removed the duplicates from the index. So if you are having the duplicates in the index like this, 2015 0101, this is 1, this is 1, for example, this is 1, and next entry is also same. Next entry is also same. So these two are the duplicates. So what I did is I said that remove the duplicate and keep only this entry. Second entry, see in the code what I mentioned. Keep first and remove the bottom one, which is duplicate of the first. Remove it. Also, I converted my date into date time format, because right now with above, with this particular set of code, it is in a string format. We have to convert our date into date time format. So I converted my time into date time format according to the hourly frequency on the basis of hours, hourly frequency. Okay, as frequency hour. Okay, and then I checked whether there are any null values in the price actual or not. There are four null values in the price actual. Okay, there are four null values in the price actual. So kindly fill them. We can't do analysis with null values. There are four, fill them. And filling I did with F fill. F fill means forward fill. Forward fill means, okay, what is forward fill? There are two kinds of fill. One is forward fill, one is backward fill. Okay, so like this 16, 16, 17. This is empty, this is empty, 18, 18. So in the forward fill, now what you have to do? If this is 17, fill this with 17, this with 17. This is called as forward fill. Okay, fill with these values. This is forward fill. And in the backward fill, you have to fill it via 18. This is backward fill. Okay, I use forward. Okay, I used forward. F fill. Okay, fine. So now I am ready with my data. So time series, I already told you that we are having a sequence of time, and in time series we are having some characteristics. These are the characteristics. One question I was being asked just in the opening of the session related to the time series. This is the characteristics of time series. Okay, we are having a trend, we are having seasonality, we are having cyclic behavior, and we are having a noise. So trend is a increase or decrease in the data along with the time. Seasonality is repeating short-term cycles over a fixed period of time, whether daily, whether weekly, whether monthly, whether whatever, yearly, whatever. That is seasonality. So we do have a seasons now. After every 4 months, we are having a season. Summer season, winter season, rainy season, then again summer season, winter season, rainy season, seasonality. So data follow a trend over, okay, we are having a seasons. Cyclic behavior, that means similar to seasonality but without a fixed period. It's not like that after every four months you will have a same, like, okay, here that's not a fixed period, not 4, it may be 6, it may be 7, it may repeat anytime. It's not like 4 fix. That is cyclic behavior. Noise means variation in the trend or the cycle. That means it may happen that some point appear in the data which is showing variation in your trend. So these are the four characteristics of a time series. Okay, fine. And divide,
Upward,
yes,
upward trend, downward trend, and constant trend
yes,
also included. Sir. Yeah. Hello.
yeah, please say.
In the characteristics of time series, also upward trend, downward trend, constant trends.
See, sir,
That's
trend
also
can be of
included.
any type. It depend upon how you can
Anytime.
explore
Okay.
more about the data. Okay,
Okay. Subtrend.
actually, sir, it is a, obviously trend. It's a behavior. Okay, one I mentioned cyclic. One I mentioned cyclic behavior. That means you are repeating after some period of time. So trend we are analyzing with respect to time. What is the behavior of your data? Whether it is upward trend, if the points are moving continuously, it is increasing. Okay, it's kind of anything, depends
Mm.
upon the data points.
Okay.
So it's a behavior. All right, so four characteristics we are having here, and we can decompose our data into these four. That is called a seasonal decompose. We can decompose using a library called a stats model. We can do that. Trend, seasonality, all these things we can do. Okay, fine. So that's what I did in my code. I use stats model, that is a statistical library. Okay, very strong library for statistical analysis. So stats model, especially for time series. Okay, so I'm taking seasonal decompose and I am taking my price, and the model which I am taking is additive. Actually, we are having two types of models. One is additive model, one is multiplicative model. Additive model assumes the sum of the components. Multiplicative model comprises of multiplication of the components. So here I am taking additive model, not multiplicative, additive. Okay, so that is the sum of the components. And here I want to decompose this price. What is the trend in it? What is the seasonality in it? Okay, all I want to check. So here I made the plots. This is the original data. Here I decompose it in a form of a trend, in seasonal, in residual. Okay, so this is original, this is the trend, this is seasonal, and this is residual. That's what I did. So decompose your data into such behavior, such characteristics. Okay, because you are having a sequential data, it definitely follow a trend. It may follow repetition, it may follow cycle also. All you have to check. So for that, you can make all these plots. You can decompose, okay, and you can show that. Fine, that's what you can do. And then after, I am using one model, that is your time series model called as ARIMA. That is called as auto regressive integrated moving average. This is the name of the model. Okay, ARIMA model. And its components are autoregressive, that means it uses past values to predict the future. That's what we have to do. Understand, your model should understand the trend and it will produce you the future. In time series, that's what happens. Understand the current trend and predict the future. Autoregressive. Okay, integrated. This is where differencing comes into the play. Differencing means subtracting the previous value from the current value. Okay, current and the previous difference. That's differencing means. That's what the differencing. Okay, here I am having d as a value. D equal to 1, it moves linear. D equal to 2, it is quadratic. So we can have the value of d. We are having moving average also. Okay, that means it uses past errors to predict and adjust the model. It uses past errors in the prediction and it will adjust your model. So for that I am having value as q. So d, q, and p. P stands for the past values. D, how many times the data is differentiated to remove the trends, and q is the number of past errors present in the model which it used. P, D, Q. These three are the important parameters in time series in ARIMA. Auto-regressive. Automatically, we are predicting the future values by analyzing the current values. By identifying the trend in the current value, we can predict the future. That's what these models do. So, okay, and we are having autocorrelation plot also. Autocorrelation means how much today's value depends on the previous value. So, for example, today's price is 10,000. What will be the tomorrow's price? That is autocorrelation. Okay, we can have a positive correlation also, we can have a negative correlation. For example, now today is 10,000, tomorrow is 12,000. It may happen that today is 10,000, tomorrow is 8,000. So, if price increase, positive, price decrease, negative. Autocorrelation. Okay, fine. So, here I have included some notes for you. Anyways, I imported my model, stats model ARIMA, autocorrelation also I imported. All right, fine. And yeah, I took the rolling mean and the rolling standard deviation. See, that's what you have to take. Rolling values also you have to take. Very much important. Why rolling? Now, let me tell you what is rolling. See, rolling means average, moving average, which calculates the average of the data points within a fixed window. Okay, we are going to consider a moving average of the data points within a fixed range. That is rolling mean. Mean, I need to calculate the mean. Okay, mean of the data points within a fixed range of values. Okay, why? Because it helps us in identifying short term fluctuations in the data. Also, you can take the standard deviation to analyze the variability in the data, to analyze the variation in the data. That's what you can do. So, rolling mean and rolling standard deviation. That's what we can take. Okay, these are the important terms in your time series analysis. Why rolling and why all these things? Because you are right now dealing with the sequential data, a data which is having a trend. Okay, so I am just looking forward for calculating the average. For example, I say that I will take the mean of the values after 3. After every 3 value, let me take a mean. This is called as a rolling mean. So, for example, you are having an entry 10, 12, 14. Before 16 come, okay, just 10 plus 12 plus 14. 10 plus 12 plus 14 divided by 3. Take the mean. Take the mean. Okay, and fill it, instead of 16, fill it with that. This is called as a rolling mean. And then again, 12, 14, and whatever be the value, take the mean, fill it. Then 14, this, take the mean, fill it. This is called as rolling mean. We have to consider rolling mean, rolling average, whatever you want to say, you can. Just to have a trend analytics. Okay, so I calculated rolling mean, rolling window, and I made the plot for them also. Here you can see. This is rolling standard, this is rolling mean, and this is the original trend, blue one. So with mean, you can see it is overlapping with the original trend. Standard deviation is below. Okay, fine. So after calculation, that's what we did. Now, before applying time series, you have to do one thing. You have to check the stationary or non-stationary of your time series. Okay, for that there is one technique called as add Fuller test. You have to apply add Fuller to check whether your, this is a statistical check to determine if your time series is stationary or not. Okay, so that add Fuller is present in stats model only. You put your price data in add Fuller and print the results in form of statistics and p value. P value is the probability value, and this is the statistical value. Statistic and probability, all these concepts comes under hypothesis testing in statistics. When I do teach machine learning, there I cover in statistics hypothesis testing. Hypothesis is a statement, okay, which we do apply over the entire population of data from a sample of data. Okay, so ADF test is used to test the null hypothesis. There is a null hypothesis is a statement which you give. So we test ADF over what? This. Okay, wait a minute. We do this test. Okay, let me fine. Yeah. So we do apply this test to check our null hypothesis, to test our null hypothesis, whether my series is stationary or not. Non-stationary data exhibits trend or seasonality, while stationary data is constant. Data is stationary, that means it's constant. Else it is having trend or seasonality. Stationary time series has statistical properties like mean, variance, autocorrelation. Stationary data is easier to analyze, easier to predict. Non-stationary is having trend. Non-stationary is having, it is exhibiting seasonality, so it is not like constant behavior. It may change anytime. So for prediction, we are checking whether my time series is stationary or not. If not, convert it, then apply algorithm. Before that, don't apply. And for that, we are having two things to check. One is f statistic, one is the p value. So f statistic, this value is the test. It measure how strongly the time series is stationary, how strongly it is in a form of stationary. And p value, it indicate the probability. Okay, and typically its value is 5% or 0.05. So I do teach in my ML also machine learning, like, okay, this is your normal plot, this is your 5%. It is called, okay, this is significant region and this is confidence region. Significant region is a region which shows the chance that your null hypothesis is going to be rejected. Confidence, that means we are having a 95% chance that your null hypothesis is going to be accepted. So we keep this as a significant p value, 0.05. If you are getting value, okay, we do compare p value greater than 5 or not. P value greater than equal to zero point 0.5 or not. That's what we check. Okay, so same thing we did here also. Okay, same thing we did here in the code. Okay, we printed f static and the p value. F static came to, sorry, p value came to be 2. That is, it is greater than 5%, 0.05. That means now I am in a confidence region. Okay, so my null hypothesis is accepted. I am having a stationary series. Okay, so I can proceed ahead. I can define any value of P, D, and Q. I can put the data, price data into ARIMA, my model, and I can fit my model. That's it. Your model got trained. Okay, here you can take P, D, Q. You very well know about P, D, Q now. I already told. Past value. Okay, how much difference? Okay, that's what you have learned here. P, D, Q. What they mean? Okay, fine. So here is the meaning of it. This is the past, number of past value, how many times the data is differentiated to remove the trends, and the number of past errors occurred. So that's what you have to consider P, D, Q as a parameters. Train your model by just taking price actual. That's it. Your model got trained. This is a summary I printed, not mandatory. We are not in the position right now to explain each and everything. Okay, but only I want to tell few things related to time series. So here I trained my model of time series. And once trained, you can perform the prediction. Okay, so I created a copy of data for DF4 and DF5. Again, I don't want to take a risk. I created a new column in DF5, that is forecast, and I use my trained model to predict all the values from starting till ending, all 35,000 values. I asked my model to predict all 35,000 values, and it did. You can see this is the actual price and this is the forecasted. Okay, this is price actual and forecasted, what my model predicted. Every time, for each and every, all entire forecasting I did. Okay, for my entire data, I printed the price actual and the forecast both, comparison to compare. This is 65, this is 57. Okay, there is error. Okay, 64, 65, 64, 64, 59, 64, 56, 50. So there might be some mapping, there might be some error. हो सकता है वो तो forecasting में. Okay, हो सकता है, कोई issue. Okay, and then I asked to forecast the future. That means I asked what are the next 24 values apart from my final date. For example, my today's date is 18 September 2024. I can ask my model to tell me next 12 predictions. This is the code for that. Okay, I asked for 24 days, and here what I can do in this particular code. Forecast index, PD, the range, date range from index minus 1. Minus 1 is the last index. From minus 1 to next 24. Minus 1 to next 24 days. That means the last value, add 24 to it. वो इंडेक्स में ऐड करो और मेरे को वैल्यू बताओ व्हाट आर द फोरकास्टेड वैल्यूज. ये कोड है उसका. Okay, and finally, I made a plot that means price actual, forecasted, and forecasted index. That is the forecast values. ये forecast values हैं. These are the forecasted values. That is out of the sample forecast. Next 24 days का है पूरा ये data. Okay, ये देख लीजिए. My actual was blue in color. Green is my in sample forecast. That means what I did here, this is in sample forecast. So you can see there is a mapping between blue and the green. अपना मॉडल बहुत अच्छा काम कर गया. You can see there is a mapping between blue and the green. And ये रेड वाला आखिरी आ रहा है, रेड, ये प्लस 24 डेज का. दिस इज नेक्स्ट 24 डेज फोरकास्ट. ओके, ऐसे हमने टाइम सीरीज भी लगा ली for energy price prediction. Okay, so in this project we have done the entire data analysis. We understood the data, we processed the data. There were many like concepts which we do covered, challenges also we faced. Okay, and in this code I have explained you the modeling part today. Though I have updated this code in front of you also related to the dysentery and also related to the imputation. My code is now changed related to the imputation, and I did shared my handwritten notes also today. I will share within the group also related to the imputation. And in imputation, I want to tell there are many misconceptions related to it. If you are having skewed data, if you are having skewed data, highly skewed data, use median for imputation. And if you are having less skewed data, very less, like if you are having nearly to the normal distribution, use mean as an imputation. Remember these things. Rest I have covered in my notes, I will share. Kindly read it. Very important concept. Okay, fine. So in these 3 days, we invested a lot of time in doing a project based upon time series and other regression algorithms for energy forecasting. Yes. Okay. Yes. Yes, Mr. Manish.
Okay, Nirmal, I tried ARIMA model. So I was looking for minute level frequency, uh, but I didn't get
This
anything.
okay.
So
This is
do you
hourly
do you
level
know?
frequency. I have used
Yeah,
on hour basis. Minutes ना actually आपका डेटा तो hourly basis पर है ना मनीष?
yeah. I was trying one of for one of my project,
ओके ओके हाँ हाँ
which
वो
I
अच्छा
have
अपार्ट फ्रॉम
developed
दैट
in
हाँ
this
हाँ
project.
अपार्ट फ्रॉम दिस ठीक है वो अलग बात है हाँ ठीक है यू प्लीज शेयर टू मी
So do we have anything uh, to
हम यूज़ कर लेंगे ना विल यूज़ मिनट ऑल्सो उसको देख लेंगे अपन कोई इशू नहीं ओके
okay?
राइट नाउ आई टुक आवरली बेसिस और मेरा डेटा ही आवरली बेसिस के हिसाब से ही था फ्रीक्वेंसी उसका आवरली था तो अकॉर्डिंगली आई हैव यूज्ड हियर ये यहाँ पर है ना आवरली वाला आपके पास मिनट का भी है सेकेंड्स का भी हो सकता है क्योंकि तो टाइम सीरीज है ये देखिए I'm using hourly frequency. So my data I took in that regards only. 1 to 24 hours है ना वो यहाँ मिनट्स और सेकेंड्स का कुछ नहीं है उनका वैल्यू जीरो जीरो है ओके सो आई यूज दिस थिंग रेस्ट यू विल सी यस यस अमित सर
Sir, I have a query that, of course, we have done all this modeling and
हाँ
forecast, I mean, time series. How to deploy this? I mean, how can end users see all these?
Okay, okay. Amit sir, I'm coming to your question. I got some questions here. One is having an eco. One is saying, okay, profit model can also be used. Time series, which model Arima we have used, and how to calculate PDQ values. See, PDQ values, na, you have to put from your side. It's certainly kind of a test which you do randomly where you can have a good results pdq if you say I put from my end that 505 the meaning you should know one is the past one is your this errors and how much times you're differentiated okay the meaning you should be knowing rest you can try an experiment from your side what could be the pdq values the one where you are getting the good results okay like predicted and actual where there is a less error that is the fine thing so experimentation पर है ये parameters ओके डिप्लॉयमेंट की बात करी आपने सो ये जो प्रोजेक्ट है इसमें डेटा सेट यदि आप मशीन लर्निंग का एल्गोरिदम का डिप्लॉयमेंट की बात करते हो यू हैव टू टेक द एंटायर प्री प्रोसेसिंग विच वी हैव लर्न द एंटायर प्री प्रोसेसिंग विल बी कवर्ड जो हमने करा है और उसको फिर अपन स्ट्रीमलीट पर डिप्लॉय कर सकते हैं AWS पर डिप्लॉय कर सकते हैं वी कैन डू दैट ओके किसी भी प्लेटफॉर्म पर यू कैन हैव अ डिप्लॉयमेंट प्री प्रोसेसिंग जो है वो पूरा ध्यान रखना लेकिन the entire code will remain the same for the deployment also. Apart from that, there is one more separate code will be made which include the streamlit. और ये जो ट्रेन मॉडल है वहां पर अपन एक्सेस कर लेंगे फर्स्ट विल सेव द मॉडल विल सेव द मॉडल सो द मशीन लर्निंग मॉडल विल बी सेव्ड इन अ पिकल फाइल फॉर्मेट डीप लर्निंग विल बी सेव्ड इन HD5 फॉर्मेट ये फाइल के फॉर्मेट रहते हैं आप हमको सेव करना पड़ेगा एंड देन वी कैन लोड द मॉडल इन अनदर फाइल दैट विल बी ऑफ स्ट्रीमलेट और पूरी प्री प्रोसेसिंग डेटा के ऊपर वी हैव टू अप्लाई ओके जो यहाँ पर लगाई है अनलेस एंड अनटिल योर डेटा इज नॉट करेक्टली प्री प्रोसेस्ड तो प्रॉब्लम होगा डेटा को मॉडल यू हैव टू द मॉडल विल एक्सेप्ट द डेटा इन द सेम फॉर्मेट विच यू हैव यूज्ड हियर तभी जाके वो आपको रिजल्ट देगा वरना नहीं देगा इट विल नॉट गिव ठीक है
Okay, yeah, just one request if you can cover
हाँ हाँ
that in
डिप्लॉयमेंट में
any
करूँगा
other.
यस वो क्वेरी आ चुका है मेरे पास आपका फर्स्ट डे पर ही क्वेरी आया था डिप्लॉयमेंट वाला सो डिप्लॉयमेंट आई विल इंक्लूड इन अपकमिंग सेशंस और भी था आई डिड लुक आउट फॉर द फाइनेंस डेटा विच इज़ द इंडस्ट्री डेटा ये भी रिक्वायरमेंट था अपार्ट फ्रॉम द केगल यूज एनी ऑफ द इंडस्ट्री डेटा आई विल बी यूजिंग दैट इन द प्रोजेक्ट अपकमिंग ये भी है एंड खास ये दो इश्यूज थे दीज टू कंसर्न्स वर देयर कि आप डेटा रियल टाइम ले लें तो फाइनेंस का डेटा आई कलेक्टेड रियल टाइम वाला ओके याहू फाइनेंस से आई टुक द डेटा हम देखेंगे उस पर आगे और उस पर भी प्रोजेक्ट करेंगे डिप्लॉयमेंट तक लेकर जाऊंगा ओके डोंट वरी
Sure, thank you.
राइट या यस अमोल सर
Hello.
हाँ, यस सर.
Sir, if we take it as a frequency in terms of the seconds,
हम्म.
so what will be the impact on the response time?
सर वो तो फिर बढ़ जाएगा ना आपका फ्रीक्वेंसी, यदि आप सेकंड्स के अकॉर्डिंग लेंगे
Uh,
तो अगेन मुझे लग रहा है अब आपका जो डेटा है वो बढ़ना चाहिए, बिकॉज इन अ मिनट यू आर हैविंग 60 सेकंड्स लाइक दैट, ऐसा कुछ. ठीक है. आवरली में सिर्फ मेरे पास फॉर अ पर्टिकुलर डे 24 एंट्रीज था, एंड मिनट्स
yes,
का होता तो
60,
60 मिनट्स का एंट्री हो जाता, सेकंड्स का तो 3600 हो जाता फिर,
3, 6,
है ना.
16 to 6.
ऐसा हो
Yes.
जाता तो फ्रीक्वेंसी सर डेटा पर इम्पैक्ट पड़ेगा आप टू अकॉर्डिंग टू विच यू आर कंसिडरिंग.
Okay.
ओके, ये चीज़ है. ऑलराइट, देखेंगे सर टाइम सीरीज. दिस इज आई टुक एडिशनल, मैंने अपने टाइटल में एम एल एंड डी एल लिखा था सर, बट दिस आई टुक
Yes, but
एडिशनल.
I am working on some parameters
ओके,
that.
ओके, यू आर वर्किंग. ओके, तो सर
Yes.
डिस्कस कर लेंगे. आई गॉट सम क्वेरीज ना रिलेटेड टू, किसी के पास मिनट्स का डेटा भी
Yes.
है एंड आप सेकेंड्स की बात कर रहे हो.
Yes.
विल चेक आउट, आप है ना, देख लेंगे इसको, कोई इशू.
Thank you, sir.
All right, thank you, sir. So let me stop presenting here. Let me stop